Start.
Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? I hope you will be fine. And I'm Dr. Hafeez Ullah. We are dealing with Laplace equation in spherical coordinates, in rectangular coordinates, in cylindrical coordinates, and so on. So far we have discussed Laplace equation in spherical polar coordinates, in two variable system, in two coordinates, and cylindrical coordinates in two coordinates, as well as in rectangular coordinates as well. But today we will deal it with in two dimension. We will discuss its general solution in rectangular coordinate system in imaginary and real space. So we start if the potential as a function of only two rectangular coordinates, then the Laplace equation can be written in this form: partial square phi over partial x square plus partial square phi over partial y square is equal to 0. This is the Laplace equation in two coordinates, in two dimension, in rectangular coordinate system. Now we introduce another set of variables. One is zeta is equal to x plus iota y, and second is eta is equal to x minus iota y. Remember, x is the real part and y is the imaginary part in this new set of variables. After that, we sum these two terms to get the value of x, and we sum these two terms to get the value of y. Sum of right hand side x plus iota y plus x minus iota y is equal to zeta plus iota. Iota y will be cancelled out with iota y, and we will get only the value of x. 2x is equal to x plus zeta plus eta, and 2 will be divided on the right hand side, is equal to half zeta plus eta. Iota is over here under the root minus 1, imaginary number. That's a complex number. It represents the imaginary part of the complex number. And the similar way, we subtract these two terms, x plus iota y minus into x minus iota y. X plus iota y, then the symbols will be changed. Minus x plus iota y is equal to zeta minus eta, or y will be equal to 1 by 2 iota zeta minus eta. Now we have partial square over partial x square. We take the partial derivative of x component, then the double partial derivative of the y component. We will have the term like partial square by partial x square is equal to partial square over partial zeta square plus 2 into partial square by partial zeta partial eta plus partial square by partial eta square. And then the derivative of the second term, partial square by partial y square is equal to minus partial square partial zeta square plus 2 into partial square by partial zeta into partial eta minus partial square over partial eta square. This will be our equation number 2. Now we will put this equation as equation number 1. Then equation number 1 will become del square phi is equal to partial square over partial zeta square plus 2 into partial square by partial zeta partial eta plus partial square by partial eta square minus partial square by partial zeta square plus 2 into partial square by partial zeta partial eta minus partial square by partial eta square. Partial zeta square will be cancelled out with partial zeta square, partial eta will be cancelled out with partial eta square. We will have the only two terms. The two terms will be left. 2 into partial square by partial eta, partial zeta. And we will sum of these two. We will get 4 partial square phi by partial zeta eta is equal to 0. Because it is equal to 0 with the Laplace equation. Del square phi is equal to 0. And the general solution of this equation, if you solve it, will become phi is equal to f1 zeta plus f2 eta is equal to f1 into x plus zeta. Put the value of zeta here. and put the value of theta here plus f2 into x minus I. So this is the general solution of the Laplace equation. This is the general solution of the Laplace equation. So far we have studied the solution of Laplace equation in different case scenarios, different requirements, but over here it is a general solution. If you have any question, later on you can ask me on my WhatsApp number. It's given in the description. You can text me, you can comment for your questions. Thank you very much.